Hello class, welcome to Unit 8 Video 1. Today we're going to look at operations on functions. The learning targets for today are that you can add, subtract, multiply, and divide polynomials and functions, and that you can also find the composition of functions, so using function notation. We have an example here. Carol owns a store where she sells birdhouses. The revenue from birdhouse sales is given by R of x. The cost of making the birdhouses is given by C of x. Okay, it says, how would you find the profit Carol earns on her sales? Well, to find profit's how much money you actually take home. Okay, so your profit is equal to, well, your revenue is the total amount of money you bring in, and C is the cost to make the birdhouses. So you take your revenue and you subtract your cost. So we have to write a profit function for Carol's sales. Well, profit will equal to the revenue, 125x, minus the cost. So if we're subtracting the cost, let's put it in parentheses. And then what we need to do is distribute the negative to simplify this. So profit is equal to 125x minus 65x minus 5,400. Then I would combine my like terms. Okay, so profit is equal to, when I add these together, 60x minus 5,400. There's my profit function. Also, we just subtracted two polynomial equations. So subtraction is one thing we're going to be doing today. So the first thing we're going to do is look at all the different things we're going to do. So we have f of x and g of x, and they are two functions, and they can be added, subtracted, multiplied, and divided together. Okay, so sum. This is all notation. Okay, so it looks f plus g, it's really, you take your f of x function plus your g of x function. And the way you calculate that is you just combine your like terms. And from now on, if I talk about combining like terms, I'm just going to say combine like terms CLT. Okay, so for our example, I'm going to go ahead and combine these two. So I would have x plus 2 plus my g of x function, so 3 of x. So I have 4x plus 2. So when I'm adding two functions, that's what it looks like. Difference, subtraction, we would have, if I have f minus g of x, it's really f of x minus g of x. Okay, so what we need to do is distribute subtraction. And then you would combine like terms. Okay, so let's go ahead and do that with our example here. We have f minus g, so it's x plus 2 minus, and let's put it in parentheses. Okay, this one there's not much to distribute the negative, so it's really x plus 2 minus 3x. Combine your like terms, I would have negative 2x plus 2. Okay, so there is for subtraction or difference. And don't forget about this notation. A lot of people struggle on the quiz because they don't realize that it's really, oh, I just add the two functions together, or I'm subtracting. Product is multiplying, so really this one just means take f of x times g of x. For this one, all you got to do is distribute. And then once again, combine like terms. So we have f of x times g of x. So we would have x plus 2 times our g of x function, which is 3x. So we're distributing. This times this, that gives us 3x squared, and 2 times 3 plus 6x. Combine like terms. There is no like terms to be combined here, so there is my answer for that one. And lastly, quotient. Okay, notation, we have f over g of x. Really just means we're taking f of x divided by g of x. Biggest thing to note here is that g of x cannot equal 0. The reason it cannot equal 0 is because you can't divide by 0, so cannot. So it does not equal 0. Right here, what we're going to do is we divide each term by the denominator. And we did this in the previous unit. Okay, so if we have f of x divided by g of x, I really have x plus 2 divided by 3x. So I break it apart. I have x over 3x plus 2 over 3x We simplify, these x's cancel. So I have 1, the 3 stays in the denominator, plus there's no simplifying here, so it's 2 over 3x. And there's my answer for that one. Okay, so those are all examples. Biggest thing here is notation and how you handle that. Now we're going to go ahead and just do some examples. So example 1, we are given f of x and g of x. We need to find the following. So A, we're just going to add them. So it's really just f of x plus g of x. So we would have x squared minus 3x plus 1 plus g of x, 4x plus 5. I would combine my like terms, and that will be my answer. So I would have x squared, negative 3x plus 4x is plus x. 1 plus 5 is 6. There's my answer for A. B. Now we're going to do subtraction. So we are really just taking f of x minus g of x. This one we're going to have to distribute a negative. So I have my f of x, which is x squared minus 3x plus 1, minus the g of x, 4x plus 5. I distribute the negative, so I'm going to rewrite the first function. Then we rewrite with the distributed negative. So negative 4x squared minus 5. So that's distributing the negative or subtraction, then combining our like terms. So those are the same, and these are the same. So I would have x squared minus 7x, 1 minus 5, minus 4. And there is our answer for B. So we did addition and subtraction. Now let's go ahead and do multiplication and division. So I'm just going to bring this out right away. So first one is A says f of x, or sorry, f times g, so it just means take your f function times your g function. So we have f of x times g of x. Okay, well, f of x is x squared plus 5x minus 1 times g of x, 3x minus 2. So all we need to do is distribute. So this times this, that gives me 3x, 2 times, or sorry, x squared times x to the first gives me x to the third. Keep distributing. I like to stay with the first term and distribute it to everybody. Now distribute the next term. So this gives us plus 8x squared minus 10x. Then we distribute the negative 1. So minus 3x plus 2. And now we just combine our like terms. There is no other x to the third, so there's that. 3x to the third. This and this, what did I do? I did something silly. I added them. Why did I add them? So let's fix that. It should have been 5 times 3, which is 15. Hopefully you caught that. 15x squared, and then I would have had 5x times negative 2 is negative 10x. Okay, that's the only one I did that on. So make sure you're careful. It's very easy to forget what operation you're doing. So multiplying, okay, so when I multiply, I should have did 5 times 3, which is 15 instead of adding them. Okay, let's combine our like terms. So plus 13x squared, and then these two I can add together, negative 13x plus 2. And that is our final answer for A. Now let's go look at B. B is division, so really we're just taking f of x divided by g of x. Okay. Our f of x function is here, x squared plus 5x minus 1 divided by 3x minus 2. Okay. This one you would divide by each piece if it was a monomial, but this is a binomial. And you could use long division for this one, but we're not going to simplify it like that. This is just fine. If it was a monomial, like in our original example, see it's only being divided by 1, then you'd want to break it apart. But since it's not, you can just go ahead and leave it like this. Okay. All right, example 3, a little bit of a word problem. If f of x represents the length of a rectangle and g of x represents the width, write a function that represents the perimeter of a rectangle. Well, perimeter of a rectangle. Well, there's two different sides. We got length, length, width, and width. So really, perimeter is equal to 2 times the length plus 2 times the width. So let's go ahead and write it that way. Perimeter, 2 times my length, f of x. So 5x squared plus 3x minus 2 plus 2 times the width, which is 4x plus 25. We would distribute the 2 to everything. Okay, and then we would distribute the 2 to everything in the width, so plus 8x plus 50. And now I go ahead and combine like terms. 10x squared plus 14x. Negative 4 plus 50 is 46. So my perimeter is 10x squared plus 14x plus 46 units. And that is it for example 3. All right. Example 4 is doing a little bit of changing gears. We're going to go ahead and we still have functions, but now we're going to find values using scientific notation. We have done this before, but just might have to be a little refresher. So for A, it says f of 2. So it means I'm going to use function f. B, it says g of negative 3. That means I'm going to use the g function. So here I have f of 2. Notice how the 2 is in the spot of the x. So it means wherever there's an x, I'm going to write a 2. So to find f of 2, it would equal to, there's an x, so I write 2 plus 3. 2 plus 3 is 5. There's my answer for f of 2. Now I do g of negative 3. So here's my g function. Wherever there is an x, because it's in the spot of my x, I write negative 3. Negative 3 squared plus negative 3 minus 1. Okay, some of us need to be reminded when we type things into our calculator. I would do parentheses negative 3, end parentheses, square it, then minus 3 minus 1. That squared has to be, when it's, especially when it's a negative, needs to be in parentheses. So that would give us 5. Okay, so g of negative 3 is equal to 5. Just remember when we type into our calculator. All right, now C is a little bit more work. It's f of g of 3. So the biggest thing is to remember to start on the inside and work your way out. So the inside is g of negative 3. What is g of negative 3? We already actually figured that one out. It's 5. So I'm going to put this in the spot of g of negative 3. It's really g of negative 3 is 5. Putting in the spot, now I have f of 5. So it'd be 5 plus 3, which is equal to 8. So my f of g of negative 3 is equal to 8. Okay, if I look at D, it's g of f of negative 1. Okay, f of negative 1. Did I find that earlier? I did not. So I have to do a little bit more work for this one. First, let's find f of negative 1. It's really negative 1 plus 3, which gives us 2. Okay, now this piece right here, what do we say it's equal to? 2. So we need to find g of 2 to find our final answer. So it's 2 squared plus 2 minus 1. This is 4 plus 2 is 6. 6 minus 1 is 5. So my answer for g of f of negative 1 is equal to 5. This is a little bit of composition, taking two functions and putting one inside of the other. Okay, so now we're going to go ahead and look at it in more general terms without specific numbers. Okay, so we have f of x and g of x, so the same as that we've been working with, but now we have to find f of g of x. There is no number this time. Before we could find the number and plug it in. Now we have to do g of x. Well, what is g of x? All of this. So it's f of x squared plus x minus 1. What does this equal? Well, I'm plugging f of all of this in. So in my f function, wherever there's an x, I'm going to write this in the spot. So I need to write this in this spot. So I have x squared plus x minus 1 plus 3. I would simplify and I get x squared plus x plus 2. So my answer is x squared plus x plus 2. This is the composition of these two functions. I took g of x and I plugged it into my f of x function. Now we're going to go ahead and do the reverse thing. we're going to do g of f of x. So we're going to take f of x and plug it into g of x. So I have f of x. F of x is x plus 3. Erasing what I got here. Now I'm doing g of x plus 3. So that means in my g function, wherever there's an x, I'm going to write x plus 3. So this is going to be x plus 3 squared plus, plugging this in the spot, x plus 3 minus 1. Now I need to simplify. Okay, people will get this wrong on their quiz because they'll forget. X plus 3 squared is really x plus 3 times x plus 3. So I'm doing like a little side note. So this gives me x squared plus 3x using FOIL plus 3x plus 9. So it's really x squared plus 6x plus 9. So I'm going to write that in the spot of this. So I have x squared plus 6x plus 9. Then I'm just going to go ahead and rewrite the rest. So combining like terms, I have x squared plus 7x. 9 plus 3 is 12. 12 minus 1 is 11. So plus 11. So g of f of x is x squared plus 7x plus 1. Sorry, plus 11, not 1. All right, so that is problem F. That's the composition of g of f of x, and that's how you would read it. So composition, we've just done 2 examples with it, but composition is suppose f and g are 2 functions, then f of g, this little o you would read, f of g of x is equal to f of g of x. Biggest thing to remember is for notation of this, see how here's an x, that's your inner part, and then you work your way this way. So that's why it's written f of g of x. So what you do is you plug x into your g function, then you plug g of x into your f of x function. Some other notations is if you have g of f of x, that really equals g of f of x like this. Okay, so here is an example. Okay, and here's a little nice thing to look at. So if this would be right here, g of f doesn't look very good. Let's see, erased. Okay, this is really g of f of x. You take x, you plug it into f, you get f of x. Then you take that, you plug it into g. That's going to give you your g of f of x for notation. That's what's going on here. So this one says we have f of x, here's g of x, find f of g, which is really f of g of, we're going to run out of room. Write it below. This is really f of g of x. So I am going to take g of x and plug it into f of x. Okay, so wherever there's an x, I plug it in. So we would have f of g of x is equal to, this plugged into here, it's 3x plus 4 squared, which is really 3x plus 4 times 3x plus 4. And then we would FOIL. And we get 9x squared minus 12x, oh, this is a plus, so plus 12x, plus 12x, plus 16. Combining like terms, we get 9x squared plus 24x plus 16. So there is f of g of x. That's what that would equal to, that composition there. All right, we have one more problem. So let's go ahead and look at 5. It's a composition one. Just going to move it so we have a little bit more room for number 5. All right, let's try this one. We have f of g of x. If f of x is equal to 3x squared minus 4x, and g of x is equal to 2x minus 1. So we are taking g of x and plugging it into f of x. So here's g of x. Wherever there's an x, we're going to plug it in. So f of g of x is equal to 3, 2x minus 1 squared minus 4. Okay, let's maybe do a little side note. What is 2x minus 1 squared? Well, it's 2x minus 1 times 2x minus 1. So I would FOIL. This gives me 4x squared minus 2x plus 1. Combining like terms, I get 4x squared minus 4x plus 1. Okay, so I have 3 times all of that. Minus 4. Now we need to distribute that 3. So we get 12x squared minus 12x plus 3 minus 4. Combining my like terms, 3 minus 4 is negative 1. So f of g of x is equal to 12x squared minus 12 minus 1. Okay, that is probably one of the trickier types of problems on today's practice. So if you have any questions, please let me know. Otherwise, that's going to be it for the video today. Have a great day, and I'll see you later.